Okay, so we are rejoining the same concept. Again, we've got something in here as our angle that's not just a straightforward x. So that's the thing that adds complexity to these questions and what we're going to focus on. Our starting steps remain the same though. We've got 2x minus 80 is equal to, and we just have to invert our cosine. So we're just taking the inverse cos as 0.45. You can do that. That should give you a number on your calculator, which is 63.256316. We can round that. We get 63.26 degrees. So nothing too bad so far. We also have to think about our angle, though. Well, 0 is less than or equal to x is less than or equal to 180. So if we double both their angles, then 0 is less than or equal to 2x is less than or equal to 360. But if we take 80 off, then 0 is minus 80 is less than 2x minus 80 is less than 280 degrees. So that detail there is important. We're just adapting our x until it looks like the type of angle that we've got. So these angles that we're getting out have got to be between minus 80 and 280. Really should keep a degree sign in there just for good measure. Now we're going to find our other angles in the standard way that we have been doing. If we are wanting to find our first angle, I'm going to sketch our cos graph. We're at 0.45, that's about there. So that first angle is 63.26 along. So we're coming 63.26 along. The matching bit of the graph is that one. So it's the same as coming back from 360 by 63.26. So 360 take away 63.26. If we do that, we are going to get an angle. That angle is 296.74 degrees. Now this is where working out this range becomes super important. I'm looking at this range up here going, hang on a second, 296.74 degrees is bigger than my 280. So I'm going to label that down. So that is out of range. Now you come to exactly the same conclusion if you use your cast diagram, just so you've got that there as well. Positive there and there. That's 360. So we're doing 360, take away our relative acute angle. And that is our relative acute angle. So this calculation turns up whichever way you do it here on the cast, but it's still out of range. So that's important. We're not going to involve this answer at the end. We don't have to because it's bigger than the range that we've worked out for our 2x minus 80s to be. I should have put my 2x minus 80 there. But can we get any negative angles? Well, it's worth checking just in what we are doing here. Now we actually do need to check both of these because these are our answers between 0 and 360. Either of these could shift to being an angle over here. So we have to check. Now this one doesn't look very likely. If I take 360 off this, it's going to be miles over here. It's going to be smaller than minus 80. But if I take 360 off an angle here, the chances are I might find one over here. So let's do that. So let's try 2x minus 80 equaling 296.74, take away 360 degrees. If I do that, I get minus 63.26 degrees. That is in range. That gets a tick. It's in range. It's bigger than minus 80. So we keep that one. Final step, we've got to actually find our x's now. We've got two angles that we can use, and we can just find our x's. So let's lay that little bit of working out. So we have 2x minus 80 equals 63.26. So 2x equals, and we're just adding 80 to both sides here, so that's 143.26. And finally, dividing both sides by 2, we get x equals 71.63. So we just worked through adding 80 to both sides, dividing by 2 gives us our answer. Same idea here, 2x minus 80 equals minus 63.26. Adding 80 to both sides, then 2x equals 16.74. And finally, dividing both sides by 2, x equals 8.73 degrees. So I've got two answers, that one and that one. The good thing about these, and I keep mentioning this as we've gone through the videos, you can always check. So on your calculator, you can do cos of 2 times that number or that number, and then take away 80. So put that in your calculator and you should get 0.45 or something that rounds to it very closely out of your calculator. So always check them. It's great. You get to the end, you can check. You can make sure that the 2 answers or 3 answers or 4 answers you've got are all valid and make sense. So have a go. There's one for you to go. So pause the video, have a go, and I will run through that one in a minute or two on the video. Awesome. So you should hopefully have had a start on this. Starting off, we are doing 3x plus 10 is equal to, and we are inversing the sign. So sine to the minus 1 is 0.88. And putting that in the calculator, we get 61.6423634. Rounding that, we get 61.64 degrees. But what ranges do our angles fit in, our 3x plus 10s? Well, 0 is less than or equal to 3x is less than or equal to, and 380 is 540. And we're wanting plus 10, so 3x plus 10. Well, if I add 10 to both sides here, that becomes a 10, and that becomes a 550. So this is the range that our angles are going to fall in that we're interested in. So 61.64, definitely in there. But let's see if we can find any others. Using our sine graph, we've got one angle happening here at 62-ish degrees. That's coming along that section of the graph. That section of the graph. So the other angle is coming back from 180 by the same distance. So we want 180, take away 61.64. Again, as ever, you could get that from your cast diagram, because sine is positive here and here. That's your relative acute angle. This is 180 minus your relative acute angle. So we're just doing that exact same calculation there. Working that out gives you 119.36 degrees. Are there any others? That's our next check. Well, this one and this one definitely fit between 10 and 550. But the sine graph cycles every 360. So let's try 61.64 plus 360 degrees. What would that give us? Well, that would give us 421.64. That's still within our range. Let's try for another one. Let's try 119.36 plus 360. What does that give us? Well, that gives us 479.36 degrees. You can check, add 360 to that or that. You are definitely getting something bigger than 550 degrees. There's no point in checking for any more, but we have got 4 possible angles. And each of those is a 3x plus 10. So we are now going to have to find our x values for 4 different things. So let's solve each of those in turn. We have 3x plus 10 equals 61.64. So 3x equals 51.64. So x equals that divided by 3, which is 17.21 degrees. So that's answer number 1. And now just repeat for each of them. So 119.36. Take 10 off, we get 3x equals 109.36. Divide by 3, so x equals 36.45. Nice to put a degree sign. This one, 3x plus 10 equals, and we've got 421.64. So 3x equals 411.64. So x equals that divided by 3, which is 137.21 degrees. And finally, 3x plus 10. So I'm just literally working through all my angles. It's a bit repetitive. But you probably don't mind that, having worked through a difficult process, to have something at the end which is just quite routine that you're doing 4 times over. That gets us 156.45 degrees. And that is our 4 answers that we have found to that question. There is a huge amount of work there. That is a really big question. It's not regular. They'll put one in the exam that is as sizable as that. They're more likely to put something slimline where there's 2 answers. It's a little bit more straightforward. But if you can tackle that, you can work your way through that. You can work with any trig equation that I can throw at you. There is one final type of trig equation I'm going to show you, but this is as difficult as it gets in terms of all of the thinking with multiple angles and sorting out crazy ranges. That is as hard as it is possibly going to get.